Good morning, guys. Today we are going to be talking about phase changes, and this is part 1. It is a little review from 8th grade because you guys might have learned this and previous elementary and stuff like that, but it goes a little more in depth. So what is the difference between the state of matter of a substance or the phase of matter of a substance? Well, the state of matter is the form taken by matter at a given temperature and pressure, and it is only uniform with respect to its physical properties because temperature and pressure are physical properties of a substance. And examples of states of matter are solids, liquids, gases, and plasma. Whereas the phase of matter is uniform with respect to its physical and chemical properties. And matter undergoes phase transitions to change from one phase to another, for example, a solid to a liquid. And the phases of matter are examples of it are solids, liquids, gases, and plasma. So states of matter and phases of matter are kind of similar, but not entirely, because phases of matter are uniform with respect to physical and chemical properties, whereas states of matter are only uniform to physical properties. So examples to make this difference more clear: at room temperature and pressure, the state of a piece of dry ice would be solid and gas phases. So the state of matter of a piece of dry ice would be solid and gas phases. At 0 degrees Celsius, the state of water can be solid, liquid, and or gas phases. The state of water in a glass is in the liquid phase. So remember, phase depends on physical and chemical properties of a substance, and this is a picture of dry ice and water in the 3 states, or phase. So you guys might have learned about melting point, which is basically when solid substance kind of changes to a liquid substance. There's a phase change. And the amount of energy required to melt 1 mole of a solid substance depends on its intermolecular forces, so what type of bonds are holding the material together and how strong they are. And the stronger the bond, the more energy is required to melt it. Another factor could be the amount of substance that there is. The more material that there is, the more energy is required to melt it. Example is NaCl, which is table salt, has ionic bonds which are stronger than hydrogen bonds in water, and so it has a higher melting point than water. The official definition of melting point taken from the textbook is the melting point of a crystalline solid, which is basically a solid in a crystal structure, or like a fixed structure, is the temperature at which forces holding the lattice together are broken and the solid becomes a liquid. So here's an example of melting. We have ice cubes and a glass of water, and the ice cubes are placed in the water, which the ice cubes have a lower temperature because the water has a higher temperature than the ice cubes. And the heat flows from the water to the ice because heat flows from warmer to cooler objects. And the heat energy, which comes from the water, is not used to raise the temperature of the ice cubes, but is used to break the hydrogen bonds that are holding the water molecules together in the ice crystal lattice. And by breaking these bonds, the water molecules can spread apart and the ice turns to liquid and it shrinks. So the ice starts shrinking, as you might have seen in a glass of ice water, until there is no ice left. This means that the melted ice water does not have a higher temperature, as stated before, and if more energy is added to the system in the form of heat, maybe it increases the kinetic energy of the liquid molecules and the temperature will start to rise. So an example, in liquid water, some molecules will have more kinetic energy than other molecules, and this is a graph that shows the distribution of kinetic energy of molecules in the liquid water at 25 degrees Celsius. And as you can see, some molecules have a lower kinetic energy than these. The molecules that have the highest kinetic energy are here at the top, and these are probably the molecules that will evaporate first if more kinetic energy is added to the system. And this shows the minimum kinetic energy needed for vaporization. So everything below this, like right here, will not vaporize because it needs more energy. It has to absorb more energy in order to evaporate or vaporize. So in this video, I've been doing a lot of verses, like one versus another, but there is a difference between evaporation and vaporization. So vapor, if you recall, is the substance that is liquid at room temperature, but in the current phase it is right now, it's in the gas phase. So vaporization is the process by which a liquid changes to a gas or a vapor. And if the input of energy used to make the vaporization process happen is gradual, then the liquid molecules, escape from the surface of the liquid. Now, the surface of the liquid, if you can see the picture here, the surface of the liquid, it's connected to fewer molecules than the molecules in the interior of the liquid. So as you can see, like this molecule, it's connected to more other molecules than this molecule at the surface. And so molecules at the surface tend to be easier to evaporate. And evaporation is when vaporization only occurs at the surface of the liquid. So why can water evaporate at cold temperatures if supposedly you learned that water evaporates at its boiling point? Let's go back to the graph. So the only reason why molecules can evaporate is because they are given some form of energy and they absorb that energy and they're able to break apart from their other connections to the other molecules. So the molecules here at the very top that had the most kinetic energy, they don't need a very hot temperature to evaporate. So these are the water molecules that are going to evaporate in cold temperatures. Let's go back to evaporation. Again, we're doing a versus kind of thing. Evaporation, open versus closed containers. So as you can see in this picture, this is an open container with water evaporating, and this is a closed container with a little flat stopper on the top so that the water vapor does not escape the container. So in the open container, all of the molecules of water will eventually evaporate out into the air. And the closed container, well, the water vapor cannot escape from the container because it's closed, and this water vapor that has already escaped from the liquid will collect over the liquid and exert a pressure, which is called vapor pressure. Vapor pressure is defined as the pressure exerted by vapor over the liquid. You'll see why vapor pressure is important later. So, boiling point. What is boiling point? Well, the textbook definition of boiling point is temperature at which vapor pressure of a liquid equals the external or atmospheric pressure. Now, vapor pressure, remember, is the pressure exerted by vapor over liquid. So when this vapor evaporates, it kind of exerts a pressure of the liquid. And in this diagram or picture, this is water, and there is a heat source that is heating the water, and we have two different temperatures of water at the boiling point, below the boiling point. Remember, the boiling point of water is 100 degrees Celsius. So below the boiling point, the black arrows represent vapor pressure, and the length of these arrows represents the magnitude of the pressure. And then the red arrows represent the external or atmospheric pressure. So as you can see, in the container that is below the boiling point, heated below the boiling point at 7 degrees Celsius, the external pressure is greater than the vapor pressure. But at the boiling point, the red arrows and the black arrows are the same length, which means that the magnitude of the pressure is the same, which kind of explains the definition. I believe this isn't a term that is going to be discussed often in chemistry, or in 9th grade chemistry, but sublimation is substances that have the ability to change directly from a solid to a gas. So this includes dry ice, for example. So some references I used to gather these materials for the video was information from ThoughtCo, which explained the difference between the phases and states of matter. It is a very helpful website for lots of chemistry topics. Like when you do a Google search, sometimes it doesn't pop up with that website immediately, but I recommend going to that website because they always have really good explanations, and of course, as always, the 9th grade chemistry textbook. In the next video, I'll be doing phase changes that release energy, so be sure to look for it. And as always, thank you so much for watching, and please stay tuned for more videos. I hope this helped.